Assalamu alaikum. Welcome to the PY-UVM Video Series. That is our lecture number 8. In the last video, we have completed our first phase, that is understanding and implementation of Coco TV based verification phase 1. Now in today's video, we are going to our view of our second phase, that is understanding and implementation of OOP based verification phase 2. First of all, we start the introduction with the OOP, that why we use OOP and what is the benefit of OOP. Python provides support for multiple programming paradigms, including object-oriented programming. That is powerful approach for organizing code by focusing on objects and their interaction. By leveraging the benefits of OOP, developers can structure code more effectively, enhance modularity, and promote code use in larger projects. The purpose of designing OOP-based testbench was to gain a comprehensive understanding of object-oriented programming concepts in Python. This will help us to design the PY-UVM framework in the future. Object-oriented programming is the foundation of expandability and reusability of UVM-based verification. It's an excellent match with Python, which provides a clean and readily understandable implementation of classes and OOP. In addition, Python supports modern object-oriented features such as multiple inheritance and dynamic class definitions. There are many concepts of OOP in which they are pointer, inheritance, abstractions, and more. But we are only focused only understanding of inheritance because it will help us a lot while creating OOP-based framework, and it will help also us in the creating of PY-UVM framework in future. In object-oriented programming, OOP inheritance is the mechanism of base an object or class upon another object. So, prototype-based inheritance or class-based inheritance, retaining similar implementation. Inheritance allows programmer to create classes that are built upon existing classes, to specify a new implementation while maintaining the same behavior, to, to reuse code, and to independently extend original class via public classes and interfaces the relationships of objects or classes through inheritance, give rise to a direct acyclic graph. An inherited class is called a subclass of its parent class or superclass. In this example, the car class inherits from the vehicle class. This means that a car object has all the properties and methods of an vehicle object, plus any additional properties and methods that are defined in the car class. For example, a car object can carry things just like an vehicle object. It can also need fuel, which is a behavior that is specific to car. And this video series of OOP-based verification, we demonstrate how to write a Coco TV test bench using classes and objects. Classes allow us to break test bench functionality into small, easier to maintain pieces. The test bench in this video series shows how we use classes to avoid copying code and making small changes. Now we are going to make different classes and in different files that are generator, scoreboard, and top file. And remember, the RTL design will be the same as it is in our last videos, that is full error. Thanks, that is all in this video. I hope you understand today's video lecture and stay tuned in the next video. We will move to the implementation of OOP-based framework.